Okay, guys, I'm on page 629 here. This is example 3 on 629. Okay, so now building on what we did yesterday, we're going to simplify this radical. We worked on simplifying the whole number in there. Remember, we're going to look for perfect squares that go into 90. Okay, and just as a friendly reminder, our perfect squares list is like 4, 9, 16, 25, 36, 49, 64, 81, so forth. Remember, this list goes on indefinitely. Okay, so the difference now is that there are variables, right? There are variables here, and we're going to have to figure out how to deal with the variables, but it's not that hard. So let's start with the 90. Let's look for the perfect square that goes in there. I believe it's 9 times 10. So I'm going to break this into, 9 times radical 10. Okay, and we'll deal with the variables in a second. All right, just remember that square root of 9 is 3, so I've got 3 radical 10. Okay, now let's leave this here for a second, and let's go back to our variables. Reminder that this is a square root, right? This is a square root, which means that we take out variables in pairs, all right? And when I say pair, I mean if and I'm going to write over here, if I had like the square root of x squared, right, that would just be equal to x because the radical cancels with the square. Does that make sense? I hope so, because you can't ask questions on the video. So you can ask them in your comments below. All right, so if I had the square root of x to the fourth, that is equal to x squared, because x squared times x squared would give us x to the fourth. And to do that backwards would be square root of x fourth equals x squared. All right, so when we take them out, we're taking them out in pairs. Look, we took 2 out and it became 1. We took 4 out and it became 2. All right, so the next question is, what do we do when they're odd? Well, if we can't take them out, if they're odd, then they have to stay in the radical. So there's 3 x's in here. I can take out a pair, right? I can take out 2, so 1 comes out, and then inside 1 will stay, right? Right? Because remember, when we take them out, they come out in pairs, right? There were 2, I took it out, now it's 1, right? Remember this? So there were 3, I took out 2, but it became just 1x out here. All right, so there were 4 y's, I can take out 4, right? Or sorry, I can take out 2 y's, right? I can take out y squared. And here I have 5 z's, I can take out 2 pairs, right? So I can take out 2, and that's going to be z to the fourth, but since there's 1 left, there's got to be a z that stays inside. Oops, I think that's a 4. I meant to write a 2 there, right? Because we're taking it out in pairs. So we got z squared, y squared, and x. So remember, here's our number, okay? And there were the variables. So the answer, what we're going to do is we're going to put our number with the variables that we took out. So I have 3x, y squared, z squared. Remember, these are the variables we took out. And then inside the radical is 10, but also that x and z, right? Because x was odd and z was odd, right? We can only take them out in pairs, so an x has got to stay in there and a z has to stay in there. So this big giant thing is our gross answer here. Okay, that is our answer. That is the simplified version of this thing, right? Okay, let's look at the guided practice. Let's look at the guided practice. How about 3A down there? I've got a radical 32. I have r squared k to the fourth and t to the fifth. Reminder, guys, we're taking out the variables in pairs. All right, so I want to start with the 32 first. Perfect square that goes into 32. 32 divided by 25 is a decimal, but 32 divided by 16 is radical 16 times radical 2, right? And we know that square root of 16 is 4. So I've got a 4 out, and I've got a radical 2 inside. Now we have to decide what to do with these variables. Reminder that we are taking them out in pairs, right? So there are 2 r's. When we take it out, how many come out? 1, right? We always take out 1. Okay, and I'm going to leave my radical symbol over here. There are 4 k's. I take them out in pairs. So how many can I take out? I can take out 2 of them. And now here's the different one. Remember, t is odd here, right? There are 5 t's. We can take out 2 of them, right? 5 divided by 2 is 2.5, so we can take out 2. We got t squared that comes out, and then because this is odd, 1 has to stay inside. Okay, so what I'm going to do is I'm going to combine this and this. And I'm going to rewrite these variables, guys, just in alphabetical order. Okay, so it's in standard form. All right, so I'm going to have my 4. I have k squared that I took out. I have r. I have t squared. And then inside the radical, remember, we left a 2 in there, right? We left a t, so inside the radical is 2. Oops, it's going a little crazy, 2t. And this is the simplified version of that original problem, 32 r squared, k to the 4th, and t to the 5th. Okay, I anticipate us having some problems with the variables. So if you have questions, go ahead and leave them in the comments. I do have a couple of problems I would like you to try. Let me go find them. Where are they? Yes, I want you to go. All right, here we go. I want you to try on page 631. Okay. I want you to try numbers 7 through 9 all. If you have questions, let me know in the comments. And I'll see you guys. Well, I guess you'll hear me tomorrow. Good luck.